In this video, we're going to do another example on two sample tests for difference in means when we have independent samples. So for this, we're going to use data file Facebook survey. So here is the question that we want to answer. We want to see if the mean number of hours spent online on Facebook is the same for males as it is for females. So we basically want to compare two population groups, the mean number of hours spent online on Facebook for two independent population groups, males versus females. So I'm gonna open data file Facebook. So in this data file, I have the number of hours spent, and I also have the number of friends that they have for 33 students, and I have the gender information of each student. So this is, of course, a case of independent sample because the samples that we have here. First of all, let me sort out the samples. So I just need to filter and sort based on the gender, A to Z, for example. So I will have my females in, let's say, yellow color, and my male students in basically with no fill. All right, so this would be my sample one, the first sample coming from female groups of students. And then I have another sample of number of hours spent from male group of students. So as you can see, these two groups are independent. We have different number of people, different number of members in each sample. And so if you take one member from this population, there is no way that you can pair and you can find the same person in the sample in the other group. So these, the members in this group are different from the members in this group, right? So they don't belong to the same person, the numbers that I see here. They don't belong to the same person. So that's basically what I mean by independence. All right, so we want to see if these two samples, the population mean for number of hours spent is the same for female versus male. So my null hypothesis would be if the average number of hours spent for females is greater than, is different. So that we want to check to see if it's the same or if it's different. So that would be a case of two-tailed type of test. So I just put females first, but it's up to you. You can put males first. This is a two-tailed type of test, so it really doesn't matter. We're gonna look at the p-value two-tailed. So equals 0, and then alternative would be mu females minus mu for males. Mu actually dealing with the number of hours online per week, not equal to 0. Null hypothesis, alternative hypothesis, level of significance, I'm gonna fix it to 5%. So level of significance, 5%. All right. This is a case of two-tailed type of test, two-tailed type of test. And for this, we need to get the test. We need to get the p-value two-tailed at the end of the day. So for this two-tailed test, and again, we're dealing with two population groups, so that would be a t-test, two sample test, t-test two sample as for mean, assuming unequal variances. So that's the type of test that I'm going to be using. So I go to data tab, data analysis, t-test two sample assuming unequal variances, and then my variable one range would be the number of hours spent per week for female students. Variable two range would be number of hours spent online for male, and hypothesized mean difference would be 0. That's the hypothesized value for the mean difference, 0. There's no label. Alpha 5%, that's perfect. And I just want to show it in the same existing sheet. So I just put it in G7 and okay. And just make sure that you get the names right. So female, males, females, males. Yes. I mean, from our observations, the sample means are not that different though. Let's see if the test supports our observation. So we need to just look at the p-value two-tailed. That's what we need. And this is obviously greater than the level of significance, so we fail to reject the null hypothesis, which means that we're going to reject the alternative and conclude that the average number of hours that people, females versus males, spend online is not statistically different. So since p-value two-tailed is not less than alpha or is greater than alpha, we fail to reject the null hypothesis, which means that we conclude with 95% confidence that the mean number of hours spent online is not different for males and females. Is not statistically different for males and females. So we don't have enough evidence to support that they're different. So I'm just gonna, so this is the conclusion. Since p-value two-tailed is not less than alpha, we fail to reject the null hypothesis and conclude with 95% confidence that the mean number of hours spent online is not statistically different for males and females. So before we close this video, I'd like to ask you this question. So again, this the t-test tool gives us only two p-values, p-value two-tailed. This is what we needed. So it's a two-tailed test. We just looked at the p-value two-tailed. But it also gives us one p-value one-tailed. So it's up to us to determine whether this is lower tailed or upper tailed, right? In case you were dealing with one tail type of test. The way we determine this, just a quick reminder, is by looking at the test statistic. And if the test statistic is less than 0, it's basically, if it's a negative, this would be p-value lower tail, which is actually the case here, lower tail p-value. And if this was positive, then the p-value one tail would be a p-value upper tail, right? So this is p-value lower tail. And if we were looking for p-value upper tail, that would be 1 minus p-value lower tail, which would be 0.58. But anyways, it's not going to change our conclusion here.